We're going to continue with chapter 5, sections 5.1 and 5.2. We are still working on the first two sections. And let me show you an application to what we did. The survey indicates that people use their cellular phones on average of 1.5 years. So that's the mean, guys. Before buying a new one. The standard deviation is 0.25 years. So sigma is 0.25 years. A cellular phone user is selected at random. What is the probability that the user will use their current phone for less than 1 year before buying a new one? So what's the chance, guys, that someone will use his or her phone only for less than 1 year before investing in a new one? Not me. I use my phone for over a year, a lot more before I buy a new one. But what is the likelihood that you will find someone who uses a new phone only for less than 1 year and then before they buy a new one? So what we need to find, guys, we need to find the probability of X less than 1. What do you think, guys? Do you think a lot of people would use their phone, the new phone, for less than 1 year, or do you think that's a small percentage before buying a new one? What's your expectation? I would say it's not a huge percentage. Most people hang on to their new phone for over a year before investing in a new one. So let's figure this out. So it's going to be normal CDF. And would someone help me with the 4 arguments here? Let me put in there. What would be the lower bound? Remember, this is a less than. So what should go here?
-1,000,000.
You got it. Then 1. Look, guys, just follow the trend, and it's always the same thing. You do the same thing. The mean is 1.5, and the standard deviation is 0.25. Okay, let's see what the answer is. Normal CDF. Okay, -1,000,000. I could keep the -1 with 99.0, but that's fine. Upper is 1. Mean is 1.5 and 0.25. And watch, guys. Ready for the answer? That's the answer. 0.228. And if I ask you to change this one to a percent, it will be 2.28%. So 2% of people will only use their new phone for less than 1 year before buying a new one. It's not a huge percentage, as you can see. So that means most people hang on to their new phone for a longer time before buying a new one. Any questions here? All right, let's do another one. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes. So that's the mean. With a standard deviation of 12 minutes. Sigma. You can see in this chapter, he has to give you the mean and the standard deviation before he asks any question. The length of time spent in the store is normally distributed. That means the distribution of the length of time is bell-shaped. We only can use those formulas if the graph is bell-shaped, and it is represented by the variable x. A shopper enters the store. What is the probability that the shopper will be in the store between 24 and 54 minutes? So if you're the manager and keeping track of time and how many staff you have to put on the floor, you want to know what is the probability, what's the chance that someone will spend at the store between 24 and 54 minutes. So if you guys, you can see what the blanks are going to be for. You have to put a 24 here and 54 there. And can someone help me now with the normal CDF? It's very easy now. What is it going to be, guys, with the 4 arguments?
24 and then 54.
24. Oops, you wanna unmute yourself, please? $24, $54, and then you have to put the mean, which is 45, and then the standard deviation. And you guys, it's not up to you to decide which one goes first. Lower bound, upper bound, number 3 must be the mean. The calculator is programmed so the third one is the mean. If you put the standard deviation by mistake, you're gonna get the wrong answer, and then 12. So let's see what this percent is. So I'm gonna turn the calculator on. I'm gonna clear this so it doesn't confuse you. Normal CDF, 24, 54. I forgot what the mean was, 45, and then 12. Look how straightforward. You don't need to do a lot of thinking, just for this one. And it's 73, 0.7333. I could have asked you this question on the test, guys, and I said, instead of the probability, I asked you what percent of the shoppers will be in the store for between 24 and 54 minutes. When I say percent, guys, it's the same thing as a probability. I would like you now to understand that the probability and area and percent mean the same thing. So if I said what percent of shoppers will be in the store between 24 and 54 minutes, you have to do one more step, guys, here to give me the final answer. What would be the step?
Multiply by 100.
Yeah, change it to a percent. That's it. Multiply by 100, so it will be 73.33%. Okay. So that means most of the shoppers are going to spend between 24 and 54 minutes. It's 73% of them. Find the probability that the shopper will be on the store for more than 39 minutes. So you just fill in the blank. That's the guided notebook. So you just put 39 here. And then we do normal CDF. Okay. Would the student tell me what the 4 arguments are? So we're going from 39 and up, greater than 39.
So the
what's
first
lower
will be
bound?
39.
The first one will be 39, I agree.
And then million.
And a million.
And then same mean and average. 45, 12.
Yeah, 45 and then 12. That's gonna do it. Even if you put 1,000 there, not a million, it's gonna work. Nobody stays at the store for 1,000 minutes. So distribute, normal CDF, 39. Watch, guys. Put as many zeros as you want. 45 and 12, no need to change it. So 0.6915. And again, guys, if he asks you what percent of the shoppers will be at the store for more than 39 minutes, you just multiply by 100, it will be 69.15%. All right. If 200 shoppers enter the store, how many of them do you think they will be in the store for more than 39 minutes? And I think this is important information for management to decide on the support, just how many staff they should have on the floor, just to help the shoppers. So if you have 200 shoppers and you want to know how many of them will be at the store for more than 39 minutes. Any ideas, guys, and how to figure out this answer based on what we did in part B, actually? We already know what percent of shoppers will be at the store for more than 39 minutes, guys. It's 69%. So if I give you 200 shoppers and I ask you how many of them will be on the store for more than 39 minutes, what would you do?
Would you take 69% times 200?
You got it. That's it. It's exactly that. So does it help to find the probability of x greater than 39 first? Yes. Multiply 0.695 from part B by 200. It's exactly that. So it's going to be 200 times 0.69. So now, guys, you can see how businesses make predictions for the future, for the week after, etc. It's all based, just on this work that you're learning right now. They try to read into the future, given, some data that they already have on hand. And so it's about 138 shoppers. Or you can make it 139. It's 138.5, so about 139 shoppers. That would be the, and then you can see, guys, the business can decide. We have 139 shoppers at the store. Well, how many workers do we have to have available in order, just to support, those shoppers? So that's an important question that businesses would have to address. Okay, next question. Let's give you some more experience using the normal CDF function. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the United States is 134, so that's the mean. And assume that the triglyceride levels of the population of the United States are bell-shaped, I think he's gonna say, are normally distributed, you can see that, with a standard deviation of 35. That's a standard deviation, keep that in mind. You randomly select a person from the United States. What's the probability that this person triglyceride level is less than 80? That would be nice. So we need to find a probability of X less than 80, guys. Okay. That's very good if you can find a person with triglyceride level less than 80, below the 134. Okay, so you do normal CDF. Okay, can you tell me what the lower bound is? You should know by now when it is a less than.
Negative 1 million.
Yeah. And then, guys, your upper bound will be this number. You cannot exceed 80. And then you put the mean. And then you put the standard deviation, which is 35. And let me see what the answer is. Already done the work. I showed you a screenshot, but let me just do it. So negative 1 million, 80, 134, and then 35. 0.0614 or 6%. So 6% of the population in the United States probably have a good triglyceride level less than 80. If I say less than 100, guys, this percentage is gonna go up for sure, because we're increasing the level. You wanna try it out? Let's try it with less than 100, which is still normal. Second distribute, normal CDF, negative 1 million. I'm just gonna make this 100. And let's see what percent of people in the United States has triglyceride level less than 100. Oh, not bad, about 17%. All right. Any questions, guys, so far? So this is how we use the normal CDF. What about if I ask you this question, guys? Hey, guys. So that's section now 5.3. Okay. Let me tell you what we're going to do. We're going to do things in reverse order. In section 1 and 2, you learned how to find the probabilities. Now I'm going to give you, find the probability, for example, of z less than 1.5. You learned how to use the table or use the calculator to do that. Here's what we're going to do in this section. We're going to give you the area to the left of z, which is 0.3632 here, for example. And we want to ask you to figure out, just the value of z. Remember, in section 5.2, we did this. Probability of z less than 1.13, for example. And then we did normal CDF. And we put -1,000,000. And then we put 1.13, and then we put 0, and then we put 1 and find the answer. You get the probability. Now, I'm going to give you the answer, and I'm going to have you find out what the value is to the left of z, which is, turns out here, for example, if we do this, let's do that one. Normal CDF, 1.1301. So we're going back to 0.1 now since I'm working with z. Okay, so this is 0.8708. Now, if I give you this probability, guys, I'm going to show you how you can figure out what the z value was, which is 1.13. So look at this example right here. The area to the left is 0.3632. What would have been the value of z? First of all, guys, I can tell you the value of z has to be negative. It can't be positive. And if you can see here, he put the z on the negative side. He didn't put it on the positive side. Can someone tell me, how do I know right away that z is going to be a negative number, not a positive number?
Because it's going to the left.
But how did we know that? Even if it's going to the left, it could be here. And then you make it go to the left.
Because it's left of the 0, the mean.
But how do we know that it has to be left to the 0? That is correct. That's what I'm trying to ask about. Okay, what is the area to the left of 0, guys? What's the area to the left of 0?
50%.
50%. Anything less than 50%, guys, is negative. It's going to give you a negative z-score. And anything above 50% is going to give you a positive z-score. So just keep that in mind. Okay, let me show you how you can find this z-score. I'm going to bring the table. So we know it's negative. I'm going to bring the negative table. I've already done a screenshot here, but I like to show it to you guys. Okay, so we know the area. We know the 0.3632. I need to find the z-score. Look how we're going to do that. We're doing in reverse order. Okay, I would like you guys to look inside the table and see if you can find the number 0.3632. 3632. Okay, and I'd like you to look right here. Okay, let's see. Somewhere here in this area. Can you see the 3632? Look on the fourth row from the bottom.
I see it. It's on -0.3.
Yeah, right here. You see? Okay. What would be the z-score that applies to this one, guys? What would be the z-score? Can you see the z-score?
Is it 0.05?
Yeah, let me show you. Just one more time here. Okay, guys, watch. So that's the target. Okay, look, it's -0.3. And then if you go up, it says 5. So the z-score is negative 0.35. And there's a demo. I just put that on the handout. 3632, look, there is a negative 0.3. And then for the column, it's 0.05. You just put them together and will become negative 0.35. And the z-score is negative 0.35. Okay, let me put another one, guys. And I'll project the table and ask you to help me with it. Okay, I'm gonna put this. Let me just sketch it. I'm gonna tell you this area, I'm gonna make it up. 0.542. And I wanted to find the z-score here. And you agree, guys, that the z-score has to be positive because it's bigger than 50%. So 0.542. Let me bring the positive table and see if you guys can give me an answer. So remember, it's 0.542. The area to the left of the target is 0.542. Okay. You should be looking here. Not down, because if you go down, the numbers are going to get bigger inside the table. So we're going to from in, out, just so we're going to from inside the table to the borders, to the column and to the row to figure out the z-score. So it's 0.542. Do you see the 0.542 anyway? Yes or no? You don't see it, correct? But do you see anything closest to 5.542? What would be the closest number to 0.542?
543.
So this one, 5438, or you could use this one, of course. So what would be the z-score here? It would be 0.1. So it is possible, guys, you don't find exactly the area that you're looking for. You just find the closest one. Probably some students would use this one that would be accepted as well. So 0.10, and that would be the z-score. So this is how you use the table, but there is a way, guys. If you are given the probability, how do you retrieve back the z-score using the calculator, which we're gonna see that in a second. But I'm just showing you how to use the table first. And not necessarily that you will be able to find the exact value that you're looking for. So if you don't, just find the one that is closest to it. I know 5478 will be too large, so I'm between this or that. I would use this one, 538, and that should
Could be in the middle, like instead of 10, like we do
You
0.
could, that's even a better answer. But the system online, sometimes it will accept the closest answer, so you don't even have. But what you said makes a lot of sense also. You could do 0.10, 0.11, take the average of the two, would be even a better answer. But the good news is the calculator will give us a lot more accurate answers, which I'm going to show you in a second after I do some more demonstration using the table. Here's another one, guys. I'm going to put one that matches in the table so you can find it easily. Okay. I want that z-scores. You can see I shaded more than 50%, so it should be a positive. And let me just put, this is the area. 9251. Remember that. Can you tell me what the z-score is? All right.
0.04.
Okay, you said it. You see it right away. Okay, what is it? It's right here. 9251. So what would be the z-score? So just go this way. You read the 1.4 and then go up there. You see the 4. So it will be not 1.04. It will be what? 1.44. Agree, guys? So that would be your z-score. Okay. Keep that in mind. And let me show you how the calculator could have done this without using the table. If there is a way to find the probabilities using the calculator, there is a way to find z-scores given the probabilities. So I'm going to show you that. This is the second and the last formula, guys, that we use in this chapter. Just two formulas. Normal CDF and the second one that comes right after. How would you read? Does anyone have any idea what that I and V stand for?
Inverse?
Inverse, yes. So it's the reverse of number 2. Inverse normal. That's normal CDF number 2. 3 is the inverse, going backwards. So watch, guys. I'm going to show you that I should get 1.44 here. Watch. Okay. The calculator wants the area to the left of my target. My target is right here. And this area here means the area to the left of the target, which I gave you already, guys. I said the area to the left of my target is 0.9251. So just put it. And since we're working with Z, guys, the mean is 0 and the standard deviation is 1. You don't need to change anything. And you're ready? Inverse norm, 1.44. It's even a better answer. I got more decimals than 2 digits, but we only require 2 digits for this. So it is 1.44. Let's go back and do this one. We got the score, it's negative 0.35. Let's see if the calculator will agree with this. So you go second and distribute, inverse norm, 0.3632, and 0.1. Negative 0.35. Okay. And when I did this one, guys, 0.542, you told me it's either 0.1 or 0.11. Let's see what the calculator would do for us here. It's going to give us a better answer. 0.542. See, halfway in between, 10547, 105. Okay. And let me show you some more applications to this. So this is how you find the z-score. You can do the inverse norm. If he gives you the area to the left of a target, you can use normal inverse norm to find the z-score. What about if he does this? That's a possible question that you're going to see in the homework online. Let's say this area is 0.235. He wants the z-score. Okay, I have the calculator ready. You said the instructor says, your teacher says you just go to inverse norm. So I'm going to go to inverse norm. And what do I do here? I gave you an area. I gave you an area to the right, guys. Remember.
Would you subtract the area from 1?
Exactly, because this formula requires an area to the left. Well, your area to the right is 235. Your area to the left, guys, you can do it here. 1 minus 0.235. I think it does compute that. If it doesn't, we'd have to do it manually. Let me see. So you guys, if you're taking notes, just take a note that this inverse norm formula, the area, I mean, if I was the one who programmed this one, I would have put area to the left, but they didn't. So it's area to the left right here. There you go. So z-score is 0.72. That's a z-score.
So when do we minus the 1? Like 1 minus the area?
1 minus the area when he gives you the area to the right. You can see how I shaded to the right of the target. This is my target. If you move to the right, that's what I shaded. But if he gives you an area that is shaded to the left, you don't do nothing. You just do it as is.
Shabazzi, my calculator just asked me if the area is to the left.
Oh,
center.
so in this case, you don't have to do that. It just say right, and then should give you the same answer. So I'm glad you mentioned this. There are some of you guys who have the newest program here, and it says area, and then at the bottom it says left, right, or center. Well, you can just put 0.235 and just put right, and it's gonna pick it up. And if you try this, let me know. It should work. It should give you the same answer.
I did left though, not right.
I'll tell you guys, let's say you didn't subtract 1. Let me show you the worst scenario. You didn't subtract 1. You can still figure out the answer. So you just do 0.235. Okay, I'm gonna just put that hint right there. Okay, watch. You look at the answer, you see it's negative. But you guys, you know that you're in the positive side. You're not in the negative side. Negative side is below 0. And look, your z-score is above 0. You know, guys, you don't do nothing. You don't redo the work. All you need, just get rid of the negative sign. And if you get rid of the negative sign, it would be what? The correct answer. So just use common sense, guys. Your answer can't be negative. So what I did here, I just did the area to the left of 0.35, but I don't want that. I want the area to the right. And they're symmetric, guys. If this is a 0.72 on the right, there should be a negative 0.72 on the left because the curve is symmetric. So whatever you get in negative, just get rid of the negative sign. It will work on the other side. All right. Exercise 9. A vet records the weights of cats treated at a clinic. The weights are normally distributed with the mean of 9 pounds and a standard deviation of 2 pounds. So we have the mean and we have the standard deviation. Find the weights X corresponding to Z scores of 1.96. So you have Z scores and we want to change them to X values. Well, let me give you the formula for Z, guys, that we use in chapter 2 and we're using in this chapter. That's the formula for Z. We're just going to do a little bit of algebra, guys, and I'd like you to help me with that. If I need to solve for X, what do I do here? Can you guys help me solve this formula for X? What would be the first step? So forget about statistics now. We're doing algebra. How do I solve for X? There is a hint. What would you do? I'm sure all of you had beginning algebra. That's why you are in this class. So what do I do to solve for X? What's the first step? Any suggestions? Do cross multiplication, guys. If you do cross multiplication, you get X minus mean times 1 equals Z times sigma. Okay, now probably you can tell me what's the last step to solve for X. One more step and I'm done. I have X minus the mean equals Z times sigma. What would be
Get
X?
rid of the mean, which is do like plus the
Yeah, you got it. You got it.
on both sides. And
That is exactly correct. And that's the formula for X. So this is a new formula for X, guys. If he gives you the Z-score and he wants the X value, this is how you do it. So now let me find the X value for Z equals 1.96. So Z equals 1.96, guys. The X value will be 1.96 times sigma, which is what? 2 plus 9. And that will be 12.92. For Z equals negative 0.44, guys. X will be negative 0.44 times sigma, according to the rule, plus the mean, which is 9. And that will be 8.12. And if Z equal to 0, we know X is going to be the mean, because Z equals 0 means the mean. So X will be 0 times 2 plus 9, which is exactly 9. So if you know Z-scores, guys, you can find X value. And if you know the X value, guys, you can find the Z-score. So you have two formulas now. This is the formula for the Z-score, and this is the formula for X. Okay. Let's do another exercise in this section. Scores for the California Peace Officers Standards and Training Test are normally distributed with the mean of 50 and standard deviation of 10. So we have the mean is 50 and standard deviation is 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? That is a very important question. And this is actually a question that a lot of schools address when they admit students to their programs. They say, well, we're going to hire the top 15, or we're going to admit the top 15% of students. How do they determine, what should be the minimum score in order to admit a student? It's the exercise that you're doing right now. So we know the average score on the test is 50 and the standard deviation is 10. And an agency, it's going to hire only the top 10% finishers, the top 10% scorers. What would be the lowest score that would make someone eligible to be hired? So let me sketch the top 10% for you guys first. Would you guys think the top 10% will be something shaded to the right or to the left? If you are a top scorer.
Right.
Right, exactly. This is the top 10%. And this is the 10% right here, guys. We need to know what this score is here. Sorry. Definitely the score has to be more than the average in order to be considered. I mean, if you are a top student in my class, definitely your score is above average. So the average is 50. This is one thing, guys, you can think of when you get confused. Do I shade top 10% to the right or do I shade it to the left? Well, if you shade it to the left, guys, you are below the mean. How can you be a top 10% student, and you are below the mean? That's impossible. So it should be an area shaded to the right. Okay. Well, you already learned how to do this using technology. I'm not going to use the table, guys. I'm just going to do it in one shortcut. So it's inverse norm. Who can help me do this in one step? Okay. Let me just bring the calculator and show you what the function requires if you forgot. Okay. What's the area here I'm going to use, guys?
0.10.
Not 10, because but this area has to be an area to the left of the target.
Is it 1 minus
10%, which is what?
0.10?
40.
90%. So area is 90%. And if you guys want the X value, not the Z-score, you can get it right away. You don't have even to change, a Z-score to an X value. Just enter the actual mean and the actual standard deviation. What is the actual mean, guys? It's 50. What is the actual standard deviation? It's 10. That's going to give you the X value. Once you don't put 0, 1 there, you don't get Z, you get X, and that's what he wants. He wants the score, not the Z-score. Ready? So it's inverse norm, 0.90, 50, and 10. This is area to the left of X. Now the other students who says that on her calculator she has right, left, center, you can just put 10% and then choose right, and it's going to give you the same answer. 62.8. So any officers who scores 62.8 or higher will be admitted to the program. That is the cutoff score. So what is the minimum score? The lowest score. The lowest score someone can get is 62.8. You get below 62.8, you won't be amongst the top 10%. You get 62.8 and higher, you are amongst the top 10%. Okay. Just one sec. I want to show you another interesting exercise that probably would trigger your interest in this. So 36, the annual per capita consumption of ice cream in pounds in the United States can be approximated by a normal distribution as shown in the figure. And let me show you what the figure is. So the mean is, I didn't know. We consume an average of 17.9 pounds per ice cream a year per person with a standard deviation of 4.4 pounds. All right. And this is adapted from US Department of Agriculture. So just keep that in mind, guys. 17.7 is the mean, and the standard deviation is
That's 17.9 actually.
17.9. So we consume a lot of ice cream, guys. That's why you go to those retail stores, you're gonna find tons of ice cream options to buy from. Okay. What is the largest annual per capita consumption of ice cream that can be in the bottom 10% of consumption? So we want to figure out if someone doesn't eat much ice cream and they are placed at the bottom 10%, how much ice cream do they eat at max? So what do you think the 10% is going to be shaded, guys? Toward the left or toward the right?
Left.
Left, it's a bottom 10%. So let's shade that one. So probably I'm among those people because I don't eat a lot of ice cream. So right here, what would be the X value? This is the mean, guys. Definitely it has to be below the mean because it's the bottom 10%. Okay, to find it, to answer part A, so that's 36. To answer A, guys, very simple. You just put X equals inverse norm. And can you guys tell me the 3 arguments? We need only 3 arguments here. Area to the left, which is what?
0.10.
110. And then 17.9, and then 4.4, guys. So let's see what makes someone a bottom 10%. Inverse norm, 0.1, 17.9, 4.4. 12 pounds of ice cream and below. So if you consume an average of 12 pounds of ice cream, and below you are at the bottom 10%. 12.3 pounds. That is the bottom 10%. Well, I'm curious to see the top 10% of people, how much ice cream do they eat? Let's see. If you want to do the top 10%, guys, all you need just to second and distribute, inverse norm, and that will be 90%, because top 10%, the area to the left of that will be 90. And I think it's going to be about 24, 25. Let's see. Okay, 23.5 pounds and more. So anyone who eats 23.5 pounds of ice cream a year is considered top 10% consumers of ice cream. So that was part A. Part B. Let's read part B. Between what two values does the middle 80% of consumption be? Okay, middle 80%. Let's explain that. Okay, let me sketch it right here and show you what the middle 80% means. Middle 80%, guys, means that this is the 80% right in the center. And we need to know those values. First value, I'm going to call it x1, and this is x2. And this is the mean right there. Any ideas, guys? How would you find x1 and x2? This area is 80%. So that's an inverse norm. And that's an inverse norm as well. If this is 80%, guys, how much is left for the tails?
10% each side.
Exactly. 10% each side. Okay. So in order to find x1, guys, all you need the area to its left. We already know it's 10%. So inverse norm 0.1, 17.9, and then 4.4. And in order to find x2, who can help me find x2? Actually, we did find it when I proposed a new question earlier.
1 minus 1.2.
Yeah, which is 90%. Because if the area to the right is 10%, the area to the left is 0.90. And then 17.9, and then 4.4. And we did find the answer actually for both of those guys. The first one was 12.3 and the second one was 23.5. Okay, so that's how you do the middle 80%. If in the book, guys, while doing homework online, he says the middle 70%, look what you do. You put 70% in here and split up the 30%. So that will be a 15 and then a 15. If he asks you for both values, you run inverse norm on 15%, and then you run inverse norm on 85%. So the two areas, guys, have to add up to 100%. Once you figure out the first one, which is 15%, the second one is automatically 85%. And then you put the mean and the standard deviation. Okay. And I kind of like number 40. That's the one that when companies write a warranty term, they use number 40. We're going to show you this one.
Professor, I have a question.
Go ahead.
So about 36, for B, what two values does the middle 80% consumptions lie? It was just the two X values we got?
Yes.
Oh, okay.
Yeah, there are middle always two values. When he says middle 60%, it's going to be two values always. Yeah.
And so we just give the 12.3 and the 23.5 for this example?
Exactly.
Okay.
Yep, you are absolutely correct. Number 40. You sell a brand of automobile tire that has a life expectancy that is normally distributed. See, it's all bell-shaped distributions. This chapter and the remaining chapters in the book is all about bell-shaped distribution. Not bell-shaped, we can't very much use them. With a mean life of 30,000 miles and a standard deviation of 2,500. All right, so number 40, the mean is 30,000 miles and the standard deviation is, what did I say? 2,500. All right, let's just hide this here. You want to give a guarantee for free replacement of tires that do not wear well. I mean, nobody would buy a tire if there is no warranty. You are willing to replace approximately 10% of the tires. How should you word your guarantee? So you guys, you sell tires. You're willing only to replace to eat up the cost of 10% of the tires. So you plan your price and your selling price so that you'll end up replacing 10% of the tires. How would you word your guarantee statement so people know whether they will be eligible, just to replace their tires or not? So you want to say, if your tire, something happens, just it gets damaged or doesn't wear well by a certain number of miles, you can bring back, for free replacement. We need to know what this number of miles is. Let me ask you to guess, guys. Would your warranty include a number of miles that is above 30,000 miles? So you say, I will replace your tires, just if they don't wear well, just after 35,000 miles. Would that be something that is possible or not? Like if someone has 35,000 miles on their tires, do you think that the company should replace, those tires? I would say no, for a very simple reason. Why is that? What's the average life of a tire? 30,000. You're not gonna replace a tire, guys, that went above average, just so that you'll go out of business. You'll end up replacing probably most of the tires because we're saying that this is the average life of a tire. So imagine, an item will last 10 years and you tell people that will replace your items, after 10 years. Everybody will end up, just replacing that. So it has to be below average if anything goes wrong with the tire. Okay, let me do a sketch and show you. So that they said they're willing to replace 10% of the tires. Where would the 10% be, guys? Toward the left or toward the right? That's what I'm trying to ask you. That's the mean. Okay, where do I shade the 10%? This side, left or right?
Left.
Definitely. If you guys replace tires that go above 30,000 miles, you'll end up replacing most of the tires. You go out of business, of course, for sure. So it has to be at the bottom 10%. Tires that were not used as much, otherwise that's not good for the business at all. So let's find out how many miles. So inverse norm, you put the 10% right here, and then you put the mean, guys, which is 30,000, and then you put the standard deviation, which is 2,500, and we can find the answer. It has to be less than 30,000 for sure. Okay, clear. Second, distribute, inverse norm, 0.10, 30,000, and what was 2,500? 26,796. You can make it 26,800. So you can make a statement. If your tire, if anything happens to the tire, and you have less than 26,800 miles or 27,000 miles on it, then we will replace, the tire for free. After 27,000 miles, that's it. The warranty will expire. So that is, and you guys, you agree with me that this is something that most companies that sell tires, just have a guarantee statement, something similar to that. Now, how do they figure this out? Here's how they figure it out. They decide what % of the sold items we can accept, just to return. Once they decide on this %, they can figure out, the number of miles. That's how they do it. So they have some people who know statistics and do the work for them in the background. Or they hire, a statistician or someone who knows mathematics to work out those numbers. And what do they use? They use the formula that I just used on the calculator to figure this out. There could be some other factors, but we're just making it simple in this exercise, guys, and showing you how the inverse norm function works. I'm going to give you a couple minutes break, but before I do that, I just want to do one more question. It's about percentiles. Okay. And then you will have been exposed to all sorts of problems in this section. I'd like you to look at number 34. Kidney transplant waiting times. The time spent in days waiting for a kidney transplant for people ages 35 to 49 can be approximated by a normal distribution as shown in the curve. Which one? 34. Okay, so the mean is 1,674. So this is the average waiting time for a kidney transplant. And the standard deviation is 212.15 days. It's right there, guys. Okay, let's see what the question is. What waiting time represents the 80th percentile? And then he asks you what waiting time represents the first quartile. Okay, let me just put this on the side and do a sketch. So we're doing exercise 34 in section 5.3. He gives us this distribution of the wait time for a kidney transplant. I hope we never hear of anyone that we know is on that list. Mean is 1,674 days, so it's about 5 years, guys. And sigma is 212.5 days. Okay. Before I answer the question, let me tell you what a percentile, again, just remind you what a percentile. He says, what waiting time represents the 80th percentile? 80th percentile, guys, means 80% of people are below that number and 20% are above it. So if I tell you guys on the next test you score in the 80th percentile, that means you did better than 80% of students, but the 20% of students did better than you. That's what the percentile is. So if I want to do the 80th percentile, the 80th percentile, guys, means the area to the left is 80%. So it will be something like that. This is the mean, which is 1,674. 80th percentile, it will be the area to the left is 80%. Now you notice that I shaded more than 50%, definitely because this is more than 50%, 80%, and I need this X value. And to find this X value, guys, you just do an inverse norm. 0.8, 1,674, and then 212.5. Okay, let's do that on the calculator. Ready? Second inverse. 0.8. Then what? 1674, that's the mean. Standard deviation. So this person is gonna wait longer than the average. 180. So if I want to round it, will be 1,853 days. So that person right here would have to wait about 1,853 days before they get a chance to replace the kidney. Now, what wait time represents the first quartile? Do you guys remember what percentile is the first quartile? The first quarter. What would that be? So I'm gonna do it, I'll sketch it. First quartile, guys, means 25%. Second quartile means the median, 50%, and third quartile means 75 percentile. So the first quartile, guys, will be less than 50%. It will be somewhere here. And that will be 25%. And we need the X value. So that's part B. And to find the X value, guys, you have inverse norm, 0.25, and the mean, which is 1674, and the standard deviation 212.5. I can tell you guys, this guy is in better shape than the other one that we did in part A because he had to wait less than the other. So it's good to be at the bottom when it comes to wait time. When it comes to scoring on the test, making money, it's good to be at the top. But in this case, the bottom is a lot better because the bottom means you wait less. And you're gonna see, it's gonna be below 1674 days. You will see that. So it will be second inverse, distribute, inverse norm, 0. What did we say, 25? And the same thing, guys. 1530. So it's about 1,531 days. So a person here would have to wait 1,531 days, whereas a person there on the 80th percentile would have to wait 1,853 days before they get the kidney transplant. Okay, so